Hello. Colonel Premnath, do you want to share your views?
Jai Hind, ladies and gentlemen. I'm Colonel Premnath, and thank you so much, Mr. Sudheer Narayanan. And I'm deeply overwhelmed and happy to be present here, and the opportunity given by ELCINA and then General Chandele, from whom I have received my accrued bonds. It's a great moment for me. I come in front of you uh, seeing the both perspectives of. Can you hear me now, sir? Thank you so much, sir. So when we are working in the field army on the requirements of sensors, uh, you know it that the way we function in the field and in the what areas where we are further enhancing or increasing our envelope of involvement, both technical and tactical. So the sensors become a very important part of our day-to-day affairs because it forms the basic structure of the layers of the sensor technology, and from sensors how we arrive at our decisions. So layer 1 are the sensors which encourages or which helps the shooter to take a decision. So if sensors are not giving the right data or giving the false data or unable to detect the data, then the decision, of course, is ultimately getting flawed. So in sensors, we have emerging technologies in radars, optoelectronics, radio frequency, various sensors which we come to deal with every day, and we try to improve the present systems using them. Some of them are ESA radars, electro-optronics and lidars and hyperspectral cameras, magnetic sensors, RF sensors, and quantum sensors, which are coming off late to the field. Next is computing. Computing we have already developed and we have made a way, somewhat significant way into the AI processors and then GPUs and FPCAs and ASICs. So the third layer is communication. Once you get the sensor data processed using the computer systems which we have and then communicating it to the backend. The communication need to be secure. It needs to be with the minimum latency, and it has to have duplicacy in one or other way. So we use the quantum technology for communications and 5G and now emerging 6G and better utilization of SATCOM as well. Once we are coming onto the communication, when you are coming onto spectrum, then comes the EW, that is electronic warfare. Our systems and our communications need to be resilient to the EW. Electronic warfare should not be taming us down, and the end results cannot be hampered by means of any kind of EW by the enemy. So in this direction, now we are going towards all the basic of signal intelligence, communication intelligence, and then electronic intelligence. From there, we are further moving towards DRFM and into the field of cognitive EW, wherein a kind of intelligence is built into the systems so that we can identify the threats which are imminent and emerging to the systems which we are operating. And final layer is the decision layer, in which we are having the decision-making loop. The smallest the loop, the best the decision is, and the less the time consumed, and the less time it is further consumed to pass on the decision to the layers in which the action has to be taken. By merely sensing, the problem is not solved. We need to act upon it. So in these decision-making loops, we are making use of IoT, then making the digital twins and bringing in the some kind of a modified Industry 5.0 standards, and then having an integrated battle management systems. We are already aware of the sensors, the plethora of sensors we have, and the key sensor technologies which we already have are flashed here. And for a person who is in the field army, may it be in the deserts or on the high altitudes or in the jungles, we are looking for the latest of technologies. We wanted the electro-optical sensors, the foliage penetrating radars. We want the radars which we can be used for sensing the penetrating the ground and sensing the threats underneath. And then we can have MEMS which are integrated with our sensors, and then some kind of a mechanical actuators which are linked with them, so that through the sensors we can act, we can take the decision and implement the decision through the one part of the sensors themselves. Some of the critical futuristic technologies which we are looking at is the semiconductor ecosystem, basically to introduce or improve the resilience towards EW. That is what we are actually interested in while making or designing our systems. And as brought out, the capability of any direct energy weapon or a microwave, we need to withstand those threats so that our systems are ruggedized. We are already using AI hardware, quantum technologies are already being built in. Photonics is another field where we are looking for some more improvements. Advanced materials for both construction of the hardware, not only the PCBs or circuits or circuit boards, entire hardware we are looking at, and then flexible electronics, mainly for wearable devices. Then we are looking for additive manufacturing in the field of electronics. It's a very nascent and emerging field in our country. So we are already taking up a project of this kind, wherein custom built PCBs can be made available for our own requirements. And finally, the trusted electronics. Colonel Tiwari just deliberated upon this point very much, so I need not speak much about it. It is basically security of our data, security of systems. So where do we need to prioritize, or how do we need to go ahead in this system? So as I already briefed and brought out, some of the areas are already been highlighted. A couple of them I would like to highlight. That is, one is Edge AI, which will be very much used in reducing the latency in decision-making process. And we need to focus towards high-density batteries. Everywhere the fight is now shifting to the utilization of power, because you have AI on board, you need more power, you have more power requirement coming up. To tackle this, we have to have systems which can withstand and consume less power, at the same time provide better quality power management systems. There is a memorandum of understanding already existing between the Indian Army and the MITI, and it has taken us a long way into the evolution of collaborative efforts, and then getting started manifesting the results on ground. And one of the fields were additive manufacturing, and there are other fields which are now started seeing the fruits. Challenges we have already discussed, so I will not waste my time on that. The strategic roadmap, I'll just take it into the 3 stages. First, we need to see at the existing systems to improve them. The first step, that is the near one, then the medium one, going on to the accessible technologies which are required by the field army and emerging in India, or we already have an ecosystem. And the third one, the longer period, maybe the ones which we are looking at to develop or to customize to our own requirements. With this, I'll conclude my talk here, and thank you once again for being such an august and respected audience. Thank you so much.
Thank you, Colonel Premnath. That was well articulated on the roadmap. With that, I think we have the view of the India defense stakeholders, and I'll transition to Mr. Sareen, who is the CTO of India Semiconductor Mission, to share his views on how the broader ecosystem is shaping and how that will help the sensor indigenization itself and critical technology.